Have you ever found yourself in an unfamiliar part of a city and wondered if this was a safe place to be? The CrimeScore algorithm, integrated with Google Maps, provides information on the relative rates of crime in a given location in the Washington, D.C. area. The CrimeScore is an algorithm designed to model the number of violent crimes per month within a 1 kilometer radius of a specified point. Violent crimes include murder, assault with a deadly weapon, robbery, and sexual abuse. The model uses nearby establishments such as bars, schools, police stations, and public housing projects to predict a crime score for the given location. For some of these features, such as bars, the number in a specified radius are calculated, and for others, like the police station, the distance to the nearest location is used. Having this information readily available in an easy-to-interpret format will give users the ability to make informed choices. For instance, if a family is looking for a hotel at which to stay and considering two different choices, the first one is considerably cheaper than the other and appears to be located fairly close to downtown attractions. With current search options such as Hotels.com, the family would have no way to determine if this area is in a place that they would feel comfortable taking their children. However, using the integrated Google search platform, a crime score will be displayed, and a family can decide if a neighborhood with a crime score of, say, 15 is worth paying an extra $30 per night, in comparison to a neighborhood with a crime score of 30. The crime score can also be effective for people shopping for new homes or apartments. They could compare the crime score of the current residents with the locations of houses or apartments to which they're considering moving. CrimeScore can also be used by city planners and concerned citizens to assess, say, proposed legislation or general changes in a neighborhood. The CrimeScore algorithm allows the user to modify various neighborhood attributes and returns an expected change in the crime score based on the hypothetical modified neighborhood characteristics. For instance, suppose a public housing project is designated around the block from your current residence. Should you be concerned about the potential impacts for your family? The CrimeScore algorithm will quantify the potential changes in neighborhood dynamics in a clear and understandable manner. CrimeScore uses an ensemble method for predicting crime known as random forest regression. The random forest algorithm begins by resampling the dataset several times. This process is known as bootstrapping. For each of these bootstrapped samples, the algorithm grows a regression tree that greedily partitions the feature space. At each partition, or node, a least squares regression is performed on the response using only a randomly selected subset of the covariates. Trees are fully grown, then pruned based off a prediction criterion that uses mean squared error. Finally, all regression trees are averaged into one multi-model ensemble. Random forests are known to be very good predictors, but they lacked interpretability. Additionally, predictions from the individual regression trees are unbiased, implying that the final ensemble model will produce a lower variance in its estimates than each of its constituent models. In other words, given a new observation of covariates, a random forest model will predict the response with a high level of accuracy, and having a large underlying data set that uses several trees will result in a more precise estimate. However, the downside to the model's use of an ensemble method is that it does not provide the user with a good intuition of or interpretation of the input variables. CrimeScore overcomes this hiccup by letting the city planner play around in a sandbox of what-if scenarios. By making changes to the underlying data, CrimeScore allows the user to see how adding schools or police stations or bars to a certain location will affect its predicted crime rate. Additionally, CrimeScore reports an importance ranking and partial dependence for covariates. These measures give the user an understanding of the relevance of a particular covariate, as well as the directionality of the relationship between the covariate and crime. For example, would you be surprised to learn that the areas near a large number of religious establishments are associated with higher violent crime? Or that the proximity to public housing projects implies more crime? We find these relationships to be invaluable bits of information for infrastructure developers and urban planners. CrimeScore relies on data drawn from the DC Data Catalog provided by the government of Washington, D.C. These data take a number of different formats. In order to make the data appropriate for use in CrimeScore, a suite of custom Python parsers was written to retrieve and parse all necessary data. These tools then loaded the data into a local MySQL database for use in CrimeScore. R and RStudio were used to manipulate the data and grow the random forest used in the CrimeScore algorithm. In addition to R-based packages, a number of third-party packages were heavily leveraged during the project. These included Plot Google Maps, Geoplot, Random Forest, PBS Mapping, and JSON. The implementation of the interface relies heavily on current-generation web technologies. The Google Maps and Google Places APIs provide maps and location information for use in exploration and calculation of crime scores. In order to calculate crime scores, the application interfaces with a separate web server hosting an instance of the R environment running the crime score algorithm. This R environment is wrapped by yet another third-party R package, Rook, which provides a web interface to the R environment. Custom scripts were written for performance tuning and to guarantee availability. Interaction and display logic in the interface itself is handled through custom JavaScript and the D3 and jQuery libraries. To begin demonstrating CrimeScore, we show the web service side of the tool. CrimeScore has been configured such that it is a publicly available tool, albeit with data currently only available for the Washington, D.C. area. Recall, however, that the variables by which a crime score is calculated are strictly spatial attributes. Any area with such spatial data available can easily use CrimeScore. These include things like streetlights, police stations, schools, etc. To begin, open a browser and browse to www.crimescore.us. Nothing loads here initially. However, we can provide coordinates as either post or get parameters in the request in order to retrieve crime scores on the fly. Here, we'll provide a single coordinate in as a get parameter and send the request. As you can see, the crime score is returned. The server actually returns JSON-P responses so that any site can consume crime scores without worrying about cross-site denial issues. Further, we can provide a full comma-separated list of latitudes and longitudes, one after the other, in order to retrieve a full array of crime scores, along with the initially requested coordinates. Consider a scenario where a family is planning a vacation to Washington, D.C. They'd like to find some places to see, a place to stay, and maybe some places to eat that are all safe for the family to be around while they're in Washington, D.C. So they go to crimescore.us. This time without the port at the end of the address. CrimeScore loads, it shows a map of Washington, D.C., and it provides a search bar at the top of the screen. First, let's say they'd just like to take a look at all the monuments in Washington, D.C. CrimeScore will take this search query, will pull Google for all the monuments around the Washington, D.C. area. It'll take each monument returned by Google, send it off to the CrimeScore server, run the CrimeScore algorithm, and tag each monument with its particular crime score. You can see this if you zoom into the map and take a look at one of the place marks for a particular crime score. This one isn't particularly applicable. Monument Services LLC. I'm assuming they're a company that cleans monuments and looks after them. This one here, though, you might know what it is, the Vietnam Memorial. It's got a crime score of 4. If they find some things that aren't particularly applicable, say this one that we just looked at, they can just remove it from the map, and it's no longer included in their list of search results. If they find another one, this one, the Dr. Samuel Hahnemann Memorial, with a pretty high crime score of 64, they can remove that one from the map because they're not so interested. You'll see, though, that a lot of results are generated because Google has thousands of results. Processing crime scores for all of those is quite an intensive process, so it takes some time for the crime score server to actually perform that query. Let's say they reset the map, all the crime scores are removed. Let's say they want to search for monuments, but they want to find monuments with a crime score of, let's say, 15 or less, which is quite a low crime score. I'd imagine we won't find nearly as many this time in our query. There's one right in the middle. It's particularly interesting. You probably know what this one is as well. It's just across from the Vietnam Memorial. This is the Washington National Monument. It's got a crime score of only 4. It provides an image of the monument, telephone number, ratings from other Google members, the Google Plus website of the Washington Monument, and the website if you'd like to view those. Let's say that's a good one.
uh, they want to include that in their itinerary. They don't want to include all of these other ones. So let's go ahead and reset and just make sure that Washington Monument is included on the map. No other ones. So there's our monument. Let's zoom in. Let's say we want to make that our point, our central point for our travels around Washington, D.C. Let's look for hotels near Washington Monument. And let's choose a nice low crime score since it'll be nighttime when we're staying there of 10. There's one hotel. I imagine a few others might pop up here. The Mandarin Oriental, Washington, D.C. That looks like a nice place to stay. We could go to the website if we want to find some more information. But let's also make sure that we find a place to eat near the Mandarin Oriental. Well, it looks like there's a few places just inside the Mandarin Oriental. Sylvester, City's Inn, and even some a little further away. These have a bit higher crime score of 9. If we wanted to stay a little safer, they could stay near the hotel, or they could venture out just a bit for some other restaurants. This is an example of how a family might use CrimeScore in order to map some places of interest that are within their particular comfort levels